本次活动，考生的目标是资深软件工程师 （Senior Software Engineer）。请大家把考生的表现和身边的 Senior Software Engineer 比较，提出评分和建议。和团队合作的过程中，我们经常需要预约和安排会议的时间。软件系统如何支持用户预约会议和管理日程呢？欢迎大家观看明道学院软件系统设计模拟面试，设计日程管理系统 Calendar System. Welcome to the interview. Today, could you help me design a web-based calendar system? Yeah, similar to Google Calendar.
Yeah, sure. Let me make a few clarifications. So, first, how many users are likely to use this system?
So we have 500 million users in total. We can assume that maybe 20% are active users.
Daily active user, so around 100 million, right? Got it. Yeah. So, and also they use the calendar system to just book the events, right?
Yes.
So just like Google Calendar.
Right.
Yeah. I think the Google Calendar I'm already pretty familiar with. So there can be like, personal event and it can be group events. So the group event can be sent to multiple users, basically. Yeah. And let me see. So let me just have a quick estimation of the scale of this problem. So let's see. So starting from the 100 million daily active users, right?
Yeah.
Let's see. So let's assume that everyone, more aggressive assumption, book one event per day with this software. And let's see how many QPS per second. Yeah, so it's around 100 requests per second. So let me just, 1,000 requests per second. So, and also, by the way, so this is actually the booking QPS, right. Because the user not only need to book the meeting, they may also need to view the calendar event, and this can be more frequent, right? So as for the read access, let's just assume like everyone check calendar maybe around 10 times per day. Yeah. So it can be 10 times 1,000 QPS around 10K QPS. That's for reading calendar events. So this is just the basic scale of this problem. And then let's start looking at the API we need to support. So first, as for the booking events, right? So the user so book calendar events. Let's see what's the request look like. So it will have, for example, the event sender, right? And also have the invitee who is invited to this event title, time slots, location, and some additional texts. There can be a lot more information, but let's just capture this for now. So the request can be this, and the response can be either succeeded or failed. So, and let's see, the user also need to check the calendar, to see what his schedule looks like in this today or this week. So maybe like we can have like query parameter, for example, for like calendar check, like just simplified from time and to time. So basically it can be check the event for today or this week or this month. So this the thing we are using, and also for the event invitation, with some event is just created and some has been confirmed, and so there are the different event has different states. So this also will be part of the response of the get calendar event API. Also, you will need to look into a particular calendar event based on the event ID. So yeah, but I feel like our main focus, correct me if I'm wrong, so it's the booking event part, because first you need to handle a large number of write heavy requests, and also it need to be careful with the booking conflict. So just to make sure, I will focus my attention in this part, the calendar event booking part. And as for the let me see. So first, starting from the rough service architecture, like for example, we have a calendar service, right? And request from a user to the calendar service, and then the calendar service gonna persist the event to the calendar event database. So pretty obvious, this database should be a relational database, because the data, like the calendar event user, whatever, they are highly relational. So before diving into the how to solve the scalability problem, I would first start from the schema, the data model of this, and just go over how a simple post APIs data flow. So let's see what are the key data we need to capture. So first, obviously, we need to capture events, right? So and also we need to have capture the users, some basic information about the users. So let me see what other information do we have. Yeah, for now, just capture events and users. And as for the event, yeah, so I've already mentioned here yeah, mostly same from the API parameters. So sender. So for one single event, there could be just one sender, but there could be multiple invitees. So yeah, in this, sender to invitee can be like one-to-many relationship. And obviously for each event, it has an event ID. Let me see. So here, yeah, there's two ways to handle the invitee. One is just to use like array or a JSON blob for this field, like and the other way is to just spread different invitee to different rows. So here I prefer to spread it to different rows, because if event is a huge event, have too many invitees, that will be very convenient to add a new invitee or remove invitee, and also it reduces the possibility of the race condition. So if we have all invitees in one huge array here, the race condition from different like add or remove requests can be a pain. So here invitee just a single string instead of a string array. Let's see other part of here. The text part is an interesting part, because it is possible for calendar invitation to have X extremely long text, right? So, but we don't need this table to be too huge. So I would consider put the text in like other places, for example, either data blob or some kind of document DB instead of in the relation DB, because later we're gonna see this table gonna be critical for our core like concurrency control. So so let's just focus on the critical part of this table. So maybe we can have some other like data for example, the event details. So as for the time, it's actually a very critical part, and it's not that straightforward to model because because the time like is some activity, right, has just a time like for 1 hour, and some maybe has a whole day event, and some event can be a whole month or an entire year because the length can be arbitrarily long. So here let's just see. So instead of time, we have like from timestamp and to timestamp. So we will go back to this later because this will there's a lot of tricky part for this. And let me see. So just a quick estimation of how many data will this table have. So let's see. So if there are, let's say 100 million new meeting per day, right? And then we're gonna so let's see, each row gonna have 50 bytes of data. Also, let me see, let's see, go over 1 year. Let's see how many data we need to persist 1 year. This just 0.1 gigabytes. So yeah, so yeah, it's around 1.5 terabytes per year. So, and if we accumulate like over 10 years, it will be around 15 terabytes like over 10 years. Of course, so this calendar system doesn't need to support data over that long period of time, like you know, having because I mean oh no, let me just go back a little bit. Yeah, so users still need to be able to check the historic event. Yeah, but the important is not as great as the current and the future events, because the future event will be has a lot more business value. So we can discuss later how to separate the historic data from the current data, but let's now focus on the critical paths. So given 1.5 terabytes per year, so yeah, it could you know, fit in it's actually it's either border of whether we need to do some more sharding or not. It can be pretty heavy for a single database instance, but it's not impossible. So we can go back to this later. And more, let me see, a more critical part is how to handle the meeting conflict. So because let me see, so the tricky situation here is that if two users want to book the meeting at the same time, so and okay, so here I think if but so my question is, so do you think the meeting room needs to be taken into consideration for this design? Because if
right. For now we just think about the users and not worry about the meeting room. And then the users, in case of conflict, they can accept or reject the invitations.
Yeah, got it. So yeah, if that's the case, we don't need to make sure. So given this requirement, we don't need to make sure like at a given location and a given user, just one event, right? So basically, different, for example, user A could be invited to like 100 different events at the same time, same location, but he could just accept one of them, right? So yeah, and I forgot to mention there's also the status. For example, is either someone like accepted, right, or invited, or something like this. So and let me see. So the let me just walk through one user flow. So when user call the book event API, right? So it's gonna write the whatever data to the DB. So this is pretty straightforward. It's just insert. But one scenario to consider is what if it's invited, for example, to a large organization, for example, 10,000 or even more people. So how will this handle? So just make sure, is this something like very realistic scenario to consider for this application?
10,000 is probably rare. So maybe we can say 1,000 is the upper bound.
Yeah. So no more than 1,000 invitees to the meeting. Right. So yeah, if one event just 1,000, yeah, so we can still do a transaction. That won't be a huge problem. And here, let me see. So I need to understand. So yeah. So now let me refine the schema here. So because the timestamp, and also as for the time duration, time of the meeting, yeah, we also need to understand, to design this, we also need to understand better the business requirements. So I would imagine that, we don't support like arbitrary meeting of arbitrary length, right? So because the meeting maybe it can be for example, okay, so the length of the meeting as well as the time of the meeting, I think we need some restriction in order for the query to be efficient. So here, for example, so let's see the get query, right? So if someone want to get let me see. So the range query here can be tricky if we don't limit the time of the meeting, like because here, right? So it's basically a query select all the meetings, right? Where time is in this interval. It's above time and smaller than 2 time. And this range query, this like 2-dimensional range query is actually very difficult to implement in the server, even if we have one of them as the index, right? Even 2 of them are already indexed. We still need to perform 2 separate queries and aggregate results, and which can be very inefficient. And also on the other hand, this kind of query is very frequently performed by the user. So yeah, so let's see how can we design for this performance bottleneck. So here or one easy way to do so is just divide the time to the time slot. So instead of having the from and to timestamp, we use the time slot ID. For example, if let's say it's just one day has 24 hours, right? For each 1 hour, you represent it as a slot. So this, yeah. So yeah, I think that could help because given this request, right, from time to time, right, when you are performing the query, you just search the time slot ID. For example, each hour, let's just use an integer. We can we can use just in hour 1 and hour 2. And first, just run this query, which can be very efficient because we can index the time slot ID. And after returning, then we can do more fine-grained filtering based on from and to timestamp. So basically, we introduce this time slot ID to help us with filtering. And further, like we can have, for example, day, month, year. So to help. Wait, let me see. Yeah, but there could be, yeah. So and here I would argue that we here how this query look like also depends on business needs. So for example, for the time range query, like in general, as far as I know, we just need to know like the daily, support daily view, weekly view, and monthly view. So right. So if that's the case, we don't we just need to see, for example, yeah, we just query by day, month, and year. That will actually even be more efficient than search from to. So to just to confirm that for the read request, daily, weekly, and monthly view, those are sufficient business scenarios. Or we need more complex.
Yeah, maybe there are some view that is from a day to some other day. So yeah, in addition to the weekly view, which is 7 day, the user may just highlight some date range, and then we need to display.
Oh, I see. So basically, sometimes user may need from date to a date, right? And then we need to return the result for that. Yeah. So yeah, if that's the case, yeah, we here we don't need the time slot, but instead we just have a day ID. So basically, each single day has a different ID. So here day, so it's not from the day of dates. So it's actually for the same day of different year, we have different ID. So this day ID uniquely identify the each day. So here let's see the index. So if we index the day ID, then we this query will be more efficient if we have like index for the day ID. Also, let me see what also forgot to mention. We need to have a primary key here. So let's see what can be the for sender plus event ID. Yeah, will be uniquely identify each event, and here the day ID will be convenient for the search, and also we may also need to index. Let me see. We probably don't need to index the event ID because when someone okay, yeah. When someone creates the event, right, they usually generally always have the sender information. So the primary key can be used to locate any event. So let me see. Yeah. So this actually. So what I just discussed of the query issue. So but let me see. So yeah. Let me see what other part of the system need to can be the bottleneck. This, yeah. So first, yeah, okay. By the way, so here, if someone search his event, right, the additional condition is he's the one be invited, and also or if someone is the sender of the event. Yeah, so just based on the invitee and sender. Okay. Okay. The other problem, yes, yeah. So when you just run this query, there could be a huge amount of meetings. Yeah, if you don't filter by the person. So how can, given the volume estimation. So, but we don't want to execute this huge query and then filter. Yeah. So which means that when there's a need to have more efficient way of retrieval this piece of information. So let's see how to speed this query up. So I think which means that we need definitely more indexing. So here, yeah, I would argue the day ID is not very helpful index because no one gonna search, on what all the meetings in this day, right? It's meaningful, only meaningful when this is jointly used by day and the person. So here the tricky thing that the person identifier could be sender or the invitee, right? But we probably need to have like more better way to model the person. Maybe we can have another column called user, okay, participant. So whenever, regardless if you are sender or invitee, you are always participant for that meeting. So if we search by day ID plus participant, so let me see which gonna be the go first. Probably participant gonna be more important here because there's two choices. One is participant go first or the day ID go first. I think actually that doesn't matter that much because if you are always search them jointly, it doesn't really matter who goes first. So because when you search event, right, search for meetings always is given participant and given the range of the dates. So with this index, I think this. So instead of having this, we just use the participant equals to whatever person. Should be good. But let me see. So, but there's a possibility that even between day 1 and day 2, there's a huge amount of meeting for participants. So, can I assume that that's not the case? For example, like So all it needs to support that kind of crazy scenario. I just want to double check.
What's the scenario? Could you repeat?
So for example, if someone wants to search all the meetings of this month, and that person may have like 1 million meetings this month, I just make sure this won't have this kind of crazy scenario.
Right, probably will be fewer than 1 million, but we could imagine someone receiving, so in a big company, usually the executives receive lots of meetings. So maybe every hour they have a meeting, and they sometimes have like 2-3 meetings booked at the same hour because people just need their time. So we can estimate based on, maximum three invitations per hour for the same person. That may be upper bound of, yeah.
So then every day just around 100 meeting, right? So and every month maybe 3 key meetings per month, right? So here, but this could still be a large number. And what if one executive search all the meetings this year, which can be like 40 K meetings per year? And if the API want to return all the meetings of executives this year, this can be a huge amount of data. So which means that we need to enable some kind of pagination mechanism to return this query. So because the thing is that so there's also no point of rendering all the meetings of this CEO in one single page. So right. So and also so
you have talked quite a bit. Maybe I hope to ask some clarifying questions for your design.
Yeah, sure.
So first, the events table, we have event ID, participant, so sender, invitee, right? So these fields like email address, or they are like user ID? So for example, invitee, is that like email address or
it can be email address, because like in the Google Calendar system, everyone is uniquely identified by the email. So
and then the participant, sender, invitee. So do we create, so if someone sends invitation to 10 participants, will we create 11 records in this table?
Yeah, I mentioned this earlier. So each participant corresponding to a single row.
Okay.
Okay.
So the information for the location and from and the status, are these just repeated across these 11 rows?
So you mean the location?
From timestamp to timestamp, they are, I guess they are the same for the same.
So it's meeting from time and the meeting to time here.
Right. So they repeat on these 11 rows.
So that's a good consideration. So basically there can be like a group event, right? Maybe 10,000 people are invited. So how to model those kind of group invitation, right? So I remember you mentioned earlier, so the group invitation is actually no more than 1,000 people. Am I right?
Right. Yeah.
So if no more than 1,000 people, and also those are not very frequent events, so this won't change our storage estimation too much.
Okay. So in this table, are there is there like a primary key for this table?
Okay, yeah, but actually you raise a very important point is that we probably need to normalize this a little bit, because the metadata of each. So as I mentioned earlier, I do have the event detail table was under consideration earlier. So event detail table, it's gonna have the basically event ID and all the detailed information of the event. So here we don't need to store like a title or the location, right? And not sure about status, but from to time is still needed because we need to support those kind of queries.
Right.
So but here I think sender invitees can be all in the event detail table, and yeah, so basically this table's main purpose is to power the meeting related queries, and this for the ground truth of the meeting. And another thing to consider is for the invitees here. Yeah, probably here. Yeah, we this is actually not that useful because it's already here. It's invitees here already here, and here maybe the acceptance status. So basically, when search for range query, it check this table, but when actually render the meeting, it actually check this table.
So this table has fewer records, or the event detail table?
Yeah, because event detail table is like a 1 row per meeting. So
Okay.
this could be multi rows per meeting, because some meeting can be sent to a lot of invitees. Yeah.
Okay. Yeah, and then if we need to update the time, reschedule the meeting, do we need to notify all the rows, or like for both tables?
Yeah. So for the rescheduling, yeah, this for the rescheduling, it really depends. Definitely, we need to change the if just the content change, right? We need to change this table, like the title, location,
Right.
time. But there's also possibility of the like add more invitee or remove some invitees. Then this will be changed, be modified, and there's a possibility that one how to say, the rescheduling events may need to update both those two tables, which implies we need to write those in a transaction.
Okay. How do we, so there are some users that are not in the system. They may have other, email address in other companies or other email providers. So how do they receive the invitation?
So because when someone sends the invitation, right, they put everyone's email.
Right.
It usually sends a huge email to all the invitees, right?
Okay.
So
in your system, where is there a service to send out the emails?
Okay, so you also want this as part of the design, so the email notification, right? So
right.
Yeah, so in that case, yeah, so for this part, yeah, so let's see, just the email notification. So let's walk through the flow. So in one when scheduling a event, right? So the service, okay, sorry, here. The user just need to talk to the Calendar service, but the Calendar service will also need to talk to the email notification service, like we can use the SendGrid or whatever. And this will actually talk to the the email server of all the participants, right? So this is the rough flow. So but here one thing need to be careful is that the persistence of the DB and this may not be like consistent, because what if this succeeded but DB actually failed to write? So I would suggest first just write to the database, and then we can use like meeting processor service just to process the change data events, and when it sees like a new event or the event modification, it will actually talk to the email notification service, and the email notification server will broadcast to the email server on the event creation or event change. So this is a rough flow. Do you want to go deeper into this part?
Yeah, this looks good for now. So we will have some kind of asynchronous job that runs after the event is created in the database. Yeah, and then let's see. So every second we have 1,000. So it's a very high email. So, lots of email sent out every second. Is one machine sufficient, or how do we?
Yeah, so here first we can do some kind of batching. So so we don't actually have to send to notification for per email, right? So and also let's see. So here basically a common way to do this is first process the change feed, and then okay, then just write them to a message queue, right? And then because the message queue here can easily scale up, and then the notification service just subscribe to the queue, and if there are huge amounts of the email, right, it will just we can easily horizontally scale the notification service, yeah, and so and talk to the email server. But I mean the detail of this part can be also really really complex, especially we need to be able to handle the failures and the retries, and how to communicate the this status to the user, because the user eventually need to know like who, if someone couldn't receive the invitation, the user needs to know, right? Right. And also if someone couldn't receive the notification, we also need to update the DB back. So there need to be a feedback mechanism here, but I think it can also be like asynchronous job to do this kind of work, because when user creates a meeting, he is not expected to immediately know the failure status. We can, if we found something wrong, we can notify the user later.
Okay, so the email address may be rejecting the email, and we can notify the user later. So the database, what is the throughput? Since we chose relational database, what type of write and read throughput do we need to handle for this database? So I already estimated the per year data could be this amount. So it actually could be a little more, because my earlier was more conservative. So as for the throughput, right? So I think it's like for this database, right? So write, yes, 1,000 QPS. Let me see. Yeah, and read can be more, but as I mentioned earlier, the some read query, especially range query, can be more resource consuming, especially if it's querying through a large range of data. So yeah. So and then for a typical relational database, do you think it can handle this type of throughput? Sounds like 1,000 QPS writes, and then maybe higher reads.
So it depends on query. So most of the query here was on just a single entry, right? Or one single, but two entry, because you and the person invited, they are both represented, most just a two-row insertion. And if we have 1,000 right just like this, it should be pretty efficient. I won't say pretty efficient, but it could handle. But there's some events maybe it needs to send to like 1,000 of invitees. So it really depends on this 100 QPS is just for mostly just small events, or there's a large amount of huge events. Maybe we can assume that there's just 5% of the events can be huge, right? So but I would say it's still around maybe no more than 3,000 rows per second relating to this DB. And also, if needed, at the time the scale could not handle, right? I already mentioned earlier, we can gradually move the old data to backup, like longer term storage. So because the recent and the future data is always more important, so that there's a way to keep this the working data set small, and the old and less important data we can actually the working data in a relation DB, the backup the older data we can even write to for example NoSQL service probably can serve that better, because for the old data we rarely actually no, for the old data is mainly read only, right? So we don't need to serve that many write traffic. But I think for the simplicity, I would still prefer using the same database technology for old and new data, just for the convenience of querying the data. So, but data can be basically sharded based on the time range. Yeah, so that's the basic idea. Yeah.
Okay, sounds good. Yeah, thank you for the interview. Our time is up. 谢谢大家参加我们这次模拟面试活动，请大家通过在 YouTube Live 的问卷链接给考生打分。打分之后，将获得我们这次会议 Zoom 直播间的链接。欢迎大家填写问卷，并参加我们直播间的讨论。请大家把考生和身边的 Senior Engineer 比较，为考生的软技能和硬技能评分，并提出一些建议。明道学院帮助大家寻找新的工作机会和职业提升。我们培训的内容包括简历改进和模拟面试、职业规划和晋升的准备、领导能力的提升和团队规划。欢迎大家扫码参加我们的微信群，以便参加未来的活动和报名1对1的培训。如果您在2天内报名我们的培训活动，请使用优惠码 LVE_520 获得20%的优惠。谢谢大家的支持。 我刚刚在mute 非常感谢大家来参加我们今天的活动，然后已经有一些朋友用这个直播间就是用我们的这个打分的链接来打了分，然后今天我们的考生是 Senior Engineer 请大家用 Senior Engineer 的标准来为这位考生打分，并提出一些建议，然后打完分之后有一个 Zoom 的链接可以进入我们的直播间，然后已经有一些朋友进入了我们直播间很高兴和大家见面和一起讨论和学习然后我现在过一下大家可以再继续打分然后我这里有一些 meeting notes， 就是一边看这个 interview 这个 interview 我们是从7:07分开始的然后在每隔几分钟我会写一个这个 timestamp 让大家可以看到就是我们时间运用方面是怎么样一个情况。好，然后我们现在看一下一开始这个 requirement gathering 然后就计算了，我看requirement gathering 的时候可能我觉得可以 gather， 就是说在 calendar system 里面不一定所有的 user 都是在这个 system 里面的所以可能要问一下，就是是不是只 handle 就是 register user， 还有怎么样去 handle unregistered user， 所以 requirement gathering 可能可以更加详尽一些吧，然后就计算了这个 queries per second 在这里，我的就是我会用这个中括号来表示当时我想到作为考官想到的一些问题然后这个1000 queries per second 是按照这个 daily active 的平均的 queries per second 来计算的那么可能日常工作会有一些 hour 是比较 peak hour所以可能不会是均匀的分布在每一秒里面所以我们需要 multiply一个 multiplier 在这个来算一下大致 peak traffic然后有可能 peak traffic 是正常平均 traffic 的5倍或者多少倍，对吧？好下面下面再看这里面有一些 API 的设计然后我的疑问就是是否可以去 handle 这个 anonymous user， 然后怎样去 create event， 然后 event 里面这个 invitee是怎么样表示这些 user是用 email 表示呢，还是用user ID 然后怎样 handle anonymous user 然后在这里13分的时候就大家可以把这个分就是那个分钟减去7，因为是从7分开始的，就是7:07分，然后这是现在7:13分然后这个relational database我觉得这里面可能要考虑一下这个 throughput， 因为首先这个平均的 throughput 是1000 queries per second， 对吧？那如果我们还有这个 peak traffic， 可能是这个的几倍的这样的 traffic， 所以可能会到达几千 queries per second 的那个写的这个 speed， 然后读的 speed 呢也是就是100,000 K， 对吧？10K 10,000然后也可能也有 peak 的这个读的 traffic，所以我的自己感觉就是我们用 relational database， 如果 single instance 可能是没有办法支持这么高的那个 queries per second 的那么可能就需要涉及到number one 可能可以考虑用这个 non-relational database， 对吧？然后另外就是如果用 relational database， 而 single instance 不能够handle 那么高的 queries per second， 那我们需要做一些 sharding， 然后能够保证我们能够写进去不然就是有的 user 就会不能够 send invitation， 对吧？写不进他的那个 invitation 进去。好然后下面有一个数据库的设计然后有一个这样的表，就是 event ID sender invitee title time location text然后在这里我有一个疑问，就是这个 invitee就是首先每一个 event 当时作为考官我的感觉就是我的直觉是，如果设计这样表，可能就是每一个 event 会有一个 entry， 对吧？然后就 event， 因为这里有个 event ID 那我就不知道，就是说有2种可能，一种是 invitee 是一个 repeated field， 不是 repeated 就是一个 array， 类似 array field 吧，然后或者是每一个 entry 就是或者说每一个 calendar invitation 会产生 multiple 这个 event entry 所以这2种都不是特别适合这个 relational database 来 store， 对吧？就是一个是我们可能如果作为 relational database 可能要做某些 normalization， 就是把这个 invitee 这个东西拆开成不同的，拆到另外一个 database database table 里面去，然后可以有 multiple entries， 然后我们不需要 repeat 这些 title time 什么这些东西在另外那个 table。假如我们用 relational database 做所以在考生设计到这里的时候，我是有一些疑问的，就是是不是需要做这个 database normalization然后另外下面就是考生做的这个这个 volume 的 calculation， 对吧？然后我觉得 volume 根据他的考虑就计算呢可能是 1.5 个 terabyte per year， 然后15个 terabyte over 10 years， 然后这个 volume 来说也是感觉是比较大的，就是说一个机器可能不容易 handle 那么大的就是15 terabyte 的这种size所以也有可能就从 volume之前就是从 queries per second 的角度，然后后面从 volume 角度也感觉这个稍微大于就是 single instance relational database 可以 handle 的这个范围。好然后对，然后这里面是我有一些疑问right 就是对 handle multiple invitee 对吧？然后还有是 email invitee 是 email 还是不是 email 下面是read write throughput 然后另外就是这 normalization 带来的问题就是，假如我们有 multiple rows， 好像后面我问过考生，然后他是说 multiple rows 对吧？那我们如果 update 这些，比如 update description、update time、location 这些，那就会涉及到 multiple rows 都要被 update 对然后就是如果我们没有 normalize， 可能会出现这些问题。好下面就是考生继续回答对，然后考生可以看到我们考生是从23分到底下好像花了挺长的时间去 optimize 一个 range query 的这个问题，而这个 range query当时就是我自己的想法就是它可能花的时间太多了，就是这个 optimize 这个 range query 为什么呢？就是我觉得它的这个整个系统可能有几个方面是考察的难点吧一个是这个 distributed system 的设计然后它这个 system 感觉就是它没有这个 notification它当时画的这个图没有 notification 这部分对吧？只有 database所以是后面才加了这 notification 对吧？当时只有这三个user calendar service database是不足以做一个完整的 calendar system 的所以这是第一个，就是怎样去设计这个系统全面的设计这个系统然后第二个是那个database schema 的 design然后这里面就是我觉得它设计的是一个没有 normalized 的一个 database所以我也是有一些疑问所以我觉得就是当然我们应该可能就是会需要花一些时间去做这个 range query optimization但是呢我的感觉就是这方面花的时间偏多了一些，就是从大致23分到38分都还在就是 optimize 这些，就是 optimize database 对吧？23到38就是花了15分钟来做 range query 的 optimization 和可能就是比如说 large meeting 有很多一个人有很多的 meeting 对吧？还是这个 range query 的这个 optimization 花了15分钟我觉得可能就是太重了，在这里面花的时间偏得太多了，因为整个 interview 只有45分钟嘛对吧？所以我们就花了15分钟就专门考虑这一个问题而且就是考生 当时并没有去问，就是这个是不是我非常关心的一个问题，可能是我会关心的问题，但是也许不是说这个考试的特别大的一个重点，或者需要花1/3的时间来讨论这么重的这样的重点。对，好然后下面我就是之前我在考虑，就是大家可以看见我之前的笔记，对吧？然后这是我之前的一些问题，在听考生的这个解答的时候，但是考生说的比较连贯，他是比较 proactive 的去 drive 这个 interview 对，作为一个 senior engineer 来说，确实是应该去 proactive 去 drive interview 但是呢我感觉就是他的提问对想要 clarify 这种 structural， 就是我关心哪个方面这样的问题，实际上没有怎么样去问，就是说我是关心哪方面的 high level 有哪些需要考察的点就 drive 的比较，我觉得偏向 aggressive 吧然后这些就是我当时积累的一些问题然后到了这个时候是我写下来，我在想到这些问题但是考生还在继续optimize for database， 对吧？然后那我们就首先我们就考察这个database normalization 这个问题，然后我就会问就是因为被 invite 这些人 invitee他们是用 email 表示，或者是他有 multiple 这个 invitee， 是不是有 multiple record， 对吧？然后考生就 confirm multiple record 那就有一个 database normalization 的问题被引出来了，对吧？然后后来考生就考虑说，那他自己最后 realize 说，有各种的 scenario，由于他在不同的 role 在 repeat the same information， 可能会处理这些问题，会有一些就是更麻烦的情况出现，对吧？就是怎么 update 这些 timestamp 怎么写，就是是不是 repeated the information in multiple database rows。然后自己就做了一个 normalization， 对吧？一个 event participant，一个是 event detail，所以这个是我一开始我想到，可能如果做 relational database 这样做是一个比较更加科学的方式，就是把一些重复的 information 放在一个 table， 只用一个 row 来表示。好那么我们再往下走，到这里的时候就我还是觉得就是说这个 system 当时就只有这3个 component， 就是 user calendar service 和 database。我觉得这个系统还是不完整，这个设计所以我就开始问这个notification 的这个 system 的问题，就是 notification subsystem 吧，对，然后带入的问题就是带入考生的这个提问就是说 user outside of system， 那我们怎么去 invite 这些人，对吧？然后他就带出了一些 notification system 的这些设计。我觉得就是他听到有这样的 requirement 之后，逐步的把这个 notification 设计到就是说我觉得还算就大体上还是对的这样的这样的设计吧。但是由于我们的时间比较紧迫，我就比较难再去追问这个 distributed system， 会有需要考虑一些什么样的情况。对，好，然后后面就是这个relational 和 non-relational database 怎么去选型，对吧？我自己觉得这个1000个 queries per second，即使不算 peak 也偏高，对于一个 relational database。就是我之前做过一些 load test for MySQL database， 还有 Redis， Kafka Q 等等，对吧？然后我就感觉这个 relational database， 至少我的 script 能够 drive 这个 relational database drive，不管用多少个 thread 都比较难超过100个 QPS。当然我的数据库没有优化过然后可能优化过能够 handle 更高一些，可能几百个 QPS。但是如果要 handle 1000到几千个 queries per second，我觉得是有一定难度的，就是可能不是那么适合的去就是用一个 relational database 或者 single instance 去 handle 这么高的 queries per second。而且就是考虑到 peak traffic 和这个读的这个 speed， 对吧？那实际上是远远超过了1000个 QPS， 可能是几万个 QPS 这样子，对吧？那我觉得可能需要考虑2种possible 的设计，一种是 还是用 relational database， 但是我们需要做某些 sharding 然后一旦做这个 sharding， 然后那个写的时候就会写和读其实都会有一些麻烦，对吧？你可能写的时候那个 shard 不是在同一个 shard 里面，那你要 multiple 那个 instance 去写，对吧？那也可以还继续用 relational database， 或者是考虑用 non-relational database， 但是 non-relational 呢可能就会有其他的一些 challenge， 对吧？比如说这个 support 这个 commit 什么这些就没有这么很好的 support，所以这里就是我只是作为考官的话，我不能够说这个是我的 opinion， 对吧？我只能够提问，就是说这个 queries 是该怎样，这么高的 queries 怎样去handle 然后考生就觉得这个1000 queries per second 可能会 generate 3000 rows per second 的 update per second 因为有的那些 meeting这个是有1000个 meeting 被 create， 每秒钟1000个 meeting 被 create但是那些 meeting 有时候会有 multiple invitees， 所以呢就所以就 create more than one row， 对吧？然后他就 estimate 就是这个3000 rows per second， 然后按照这个 rows per second 再乘以一个 peak 的那个 traffic 的话，那可能就相当高了，就是写的那个速度需要比较高才行所以我觉得考生当时还是 insist 就是 relational database， 但是自己可能也 realize 说，可能 on the borderline 不一定能够 handle， 对吧？然后说是我们可以把它 shard by time range， 我觉得 shard by time range 是没有问题，但是写的时候可能还是会集中到某一个 shard 里面。因为就是最 active 那个 shard， 就今天和这个星期，对吧？有可能是放在同一个 shard 里面的，那个 shard 主要写都会写到那个里面去然后但是旧的那些实际上只是 support 读的，所以它即使 shard by time range 也可能没有办法去减轻这个写的这个 load， 但是它可以也许能够减轻读的这个 load， 但是不能够减轻写的 load。所以可能还需要除了 shard by time range 之外如果我们还是一定要用 relational database， 可能还需要 shard by user 或者 shard by要不然就发邮件那个人或者发 invitation 那个人，要不然就是收 invitation 那个人，反正就是 some kind of sharding based on 这个 user 才可能不能够光是靠那个 time range这是我自己的想法，就是也许还可能 shard into days。Base of day 也许也可以，对吧？但就是不是当时就是感觉不是那么的没有觉得有一个很好的答案吧，考生可能没有给出一个很好的答案，也还可以，对，就是好。然后但是我们当时的time 已经 run out 了所以就这样结束了所以总体来说呢我觉得考生是一个比较有经验的，也能够就是说能够 drive the interview， 对吧？然后也能够迅速的incorporate 这个 feedback 和增加这个 design。当我提到就是这个系统设计不是很完全的时候但是可能遗憾的就是它这个 database 里面在某一个阶段就是 optimize 那个 range query 的时候花的时间太多花了一个15分钟的时间所以就造成了high level 把其他的能够使用的时间就减少了很多这是我总体的感觉。好很感谢大家给我们的考生打分，然后现在看一下我们的考生的这个 feedback 怎样。好然后这里是红色表示 meets expectation， 然后黄色表示 needs improvement然后蓝色是 exceed expectation。好，然后这里第一个是这个 gathering requirement，然后总体是大致是 meet， 对吧？然后稍微偏向 needs improvement， 在 gathering requirement 的时候，是有一些也许可以稍微展开一下的比如说需不需要考虑send notification， 对吧？还有怎样去 handle login user versus not login user， 所以这个 functional requirement 的时候，可能是能够也许是可以再问一下这个具体的这个更加具体的一些 requirements。好然后底下是decisions and justifying trade-offs 大家觉得是基本上是 meets expectation。好，然后这个是 clear presentation concise language 也是 meets expectation 然后下面是driving the flow of the interview 然后是大致是 about right 然后 too aggressive 就1/4就偏向我们的偏向大家觉得是稍微 aggressive 了一些所以这个跟我的感觉也是类似吧就是有时候我插不上嘴，因为考生在不断的 drive 和就是比如说在 optimize 这个 range query 的时候我有时候感觉插不上嘴好然后下面是这个 design quality 然后基本上 meets expectation 对吧然后稍微有一些needs improvement在底下是knowledge of existing software and hardware solution然后也是基本上 meets expectation 然后稍微偏向 needs improvement然后 software solution 这里面可能能够涉及到的就是这个 database 的这个database 的这样的设计对吧选型和这个 database design 可能是我们对 existing solution 的一个理解所以可能这里面可以更加详细的谈一下这个 trade off 对吧就是 relational versus non-relational 好然后下面一个是 awareness of project life cycle and larger context然后也是基本上 meets expectation然后稍微偏向这个 needs improvement 好非常感谢大家的这个feedback 那如果大家有什么想法的话也欢迎开麦来说一下好看看大家有没有什么想要讨论的或者有什么建议
我想说一下，就是说，如果sharded by 那个 time range 的话，是不是很合适？因为很多人都是看当天的 calendar， 所以的话，就是你如果是当天的话，很容易就是在一个 shard 上造成 hotspot 这个问题，所以我觉得这个是不是很合适？对，所以大家有什么其他意见吗？而且我觉得，就是说它的 red QPS 是远远超过10K per seconds。实际上像那个Google Calendar 的话，可能会达到 million 这个级别的。我觉得单纯用 database 可能解决不了这个问题。不是，我不知道大家怎么想，反正我觉得可能会被 push back。
对，然后在我们的 YouTube channel 里面有位朋友建议说，是不是缓存当天的 meeting 或者是缓存3天的 meeting 可能就是说如果那个读的
当天是一定要缓存的，当天的 cache 是一定要缓存的。那个但是我不知道这个时间应该怎么走，但是我觉得当天是一定要缓存。而且我觉得应该是有2个 database， 一个是 event， 还有一个是user 跟 events 这2张表。user events 这张表应该是非常大的。所以传统的relational DB 应该是哪怕是 sharded 的也是非常困难去支持它的，因为这个数据它包括考生也说过，可能就是每年的话都是 TB 级别的。所以我是担心如果在 TB 级别上的数据要你维持 index 的话，可能是件很困难的事情因为传统的 relation database 都是用 binary tree。binary tree 的话，最好不要支持7层以上的 B tree 的架构但是它 TB 的数据的话，肯定是远远超过7级了。
好 difficult to maintain index on a large data volume 对，那你有什么建议吗？就是如果我们不用 relation， 是不是就说会建议去用？
我们用 NoSQL 这个途径的话，肯定是用 NoSQL 对吧？ 所以我就觉得为什么要用 relation DB，因为 TB 级别的数据你还要维持一个 index 不只是你要维持一个 user 的 index， 还要维持一个 event index 然后还要维持一个 time range 的 index， 这3个 index 的都不是 sparse index， 所以它消耗的那个空间和那个就是计算量都是非常大的。
好，所以建议用这个 non-relational database， 由于我们的 volume 和这个 volume 很大，和 throughput 也很大。好，非常感谢。那看看大家有没有什么建议和想法。
老师，我想问一下，怎么去解决它的 conflict 的呢？就是在定的时候，如果说某个 user 他已经那个时间他已经有了其他的一个 meeting， 在 database 里我们怎么去 query 发现它的 conflict？
我觉得好多 Calendar system 都是 ignore 这个问题的。就是你如果试下 Google Calendar 的话，你同一个时间段可以可以就是那个接受不同的 events 的邀请。
OK， 所以就是取决于
对，但是
user 他到底
对，但是你的想法很好，其实这个东西是应该先声明的。但是我觉得，如果你要解决这个 conflicts 的话，可能会花一定的时间。但是因为当前很多系统都不会解决这个 conflicts， 但是还是需要在面试前要声明一下。
I see， OK。
对，就是可能就是default behavior 就是帮助可以让用户接到 multiple invitation， 但是用户就手动的去 resolve conflict， 对吧？就是自己去决定是不是 reject 还是 accept。这个是用户的方面。如果是有 meeting room， 对吧？那 meeting room 可能就得去设置是自动 accept 还是自动 reject 这些 invitation。对
meeting room 有些人他是前20分钟参加一个会，后20分钟才参加一个会，这个其实也不是很矛盾，对吧？因为有些人对吧？有些人他只是参加会议的上半部分，然后他接着又去参加另外一个会议，我觉得这个根本不是什么问题。
对，就是有时候会team event 两个不同的 tag lead 不同的 team， 对吧 ？book 了 same meeting room， 那种就会比较麻烦，就是对
这里面有 meeting room 的概念吗？我这边好像
在这里面没有。对，在这里面就是我当时考生问过我，就说这个 scope out 这个 meeting room， 但是 meeting room 可能会如果要 resolve conflict 会更加复杂一些。对，可能 meeting room 自己会有一个 data structure 去自动去 resolve。
是 events 就可以解决了。events 的时候，你对那个每个 events 它的location 跟它的time interval 设一个 unique 的 check 就行。
你说是event 是吗？
对，你 event 的时候如果有 location 的话，对吧？你 location 再加上from time 跟 to time， 对吧？然后你设一个unique 的 index 就行了，对吧？你在创建的时候就可以杜绝这些现象发生了，对吧？
对 ，start time end time 就是 assume， 假如我们用 relational database 来做这个事情 ，relational database 就可以把这个东西 reject 掉，因为那个会 violate 一个 unique index based location start time end time。
对，这个 DB 层的可以做，那个就是 API REST API 那一层也可以做，对吧？这个其实挺简单的，这个解决方式挺简单的。
对，如果我们用 non-relational database 来 support 的话，也许它就不帮我们 reject 这个东西，那我们就需要自己去锁，或者是自己去做 some other system。
其实这里面 non-SQL 还有一个问题，就是一个分布式 transaction， 就是刚才老师您也提到了，就是说你如果 update 一个 event 的话，它对应的 user event 那个可能在不同的 sharded 的 instance 上。
对，
那这个肯定是一个 transactional request， 对吧？
对
吧？就是那你这里怎么handle 这个 transaction 就是你去 update 或者是 create 一个 event， 然后让 user 去支持的话，然后你再 cancel 这个 event， 然后这个东西的话，就是应该是一个 transaction 的一个 request。就是我不知道考生有没有提到这里有一个 atomic 的要求，对吧？
对，就是要不然就全部都存下来，要不然就全部都不存，不能够一半人 invite， 一半人没被 invite。
对。
好，大家还有什么想法？
不好意思，可能 miss 掉了。就是说，刚刚那个同学提到，就是如果 time， 我觉得 time 确实不是一个很好的一个 starting key， 但是用哪样的 starting key 会更一个 better choice？
他们的话，因为我前面提到了，因为绝大多数人都是看当天的 calendar， 对吧？
对。
所以的话，你用 time 你的 time 那个做一个 sharding 的话，很容易产生 hotspot 的问题，对吧？
对，就是说你觉得什么样就是一个 better choice？ 是用 user ID 还是？
这个一般是设计生要讨论的。一般如果是用 NoSQL 的话，一般是用 user event 那个是用 user ID 作为 sharding 比较好一点。
OK， 好的，谢谢。
这是个 open question， 就是说其实这边就是一般就会讨论你用哪一个key 来作为 partition， 就是你的 partition key， 这个都是可以讨论的，就是对，因为其实对，其实的话可以讨论一下这里。
那老师有什么 idea 吗？然后那个对，就是老师有什么 idea 吗？在这个就是 partition key 的选择上面，还有那个 sort key 的选择上面。
对，我觉得 partition key 就是有两个，可能有两个考虑吧，对吧？一个就是说你写的时候，如果 就是写的时候和读的时候，对吧？然后写的时候最好能够只写到一个 partition， 然后读的时候也最好只从一个 partition 读，但是这个可能没有办法达到这两个要求。然后我们首先第一就是我们 partition 最好能够 somewhat even， 对吧？就是那我们用 time 来做 partition key， 就有可能产生 hotspot emote， 就是今天和这一个星期的可能是最 hot 的 partition， 所以可能并不是很适合用 time，用 user 的这个比如 hash code 什么，对吧？然后可能就相对来说会均匀一些。希望就是说这些 heavy user 会由于这个 hash code randomness 会 distribute 到不同的 shard 上面。那如果用 user 的话，就有一个疑问，就是说，那我们我们是按照这个 sender，就是在写的时候，我们当然是希望只写到一个 shard， 对吧？那我读也希望只从一个 shard 来读。那么如果我们读的时候要从一个 shard 来读，那就是说我们可能就用 user ID， 对 user ID， 首先我们决定用 user ID， 那我们那就会造成了要写到不同的 shard 里面，对吧？就是假如我要 invite 5个不同的 user， 然后这个5个不同 user 就正好跑到了不同的5个 shard 那里，那我就写的时候就比较困难一些。所以就是没有一个没有一个 perfect 的这个 answer， 就是说既能够写到同一个 shard， 又能从同一个 shard。
我这里补充一点，就是说，因为这个是个弱写强读的一个系统，对吧？所以的话，它的 reader request 是优先要考虑的。所以这时候呢，就是说，如果你是作为invent 的 ID 作为主件的话呢，因为很多人去查 Calendar 的时候都是用 invent 的 ID， 对吧？就是说我看一下我当天有多少会，对吧？一般我都是 invent， 对吧？ 所以的话呢，用 event ID 作为它的pagination key 比较有优势，因为刚才那个同学就是 Elisa 也提到了，就是说你查当天的 meeting 也便利所有的机器那就是说，如果你用 event ID 作为你的 pagination key 的话，那你就不需要去查所有的 shards， 你只要查你的 ID 所在那个 shards 就行了，就解决了刚才老师提到的，就是说就是说我的 query 就尽量要用尽量少的 query 字数来实现，对吧？因为这个系统是一个强度的系统，对吧？虽然就是说你 invent 的时候邀请别人的时候写的时候会 update 很多的 shards， 但是因为你写的 request 相对比较少，对吧？所以这个性能的牺牲做权衡是可以达到的，对吧？
对，应该是用这比 invitee 和 sender 对吧？invitee 是更加好的选择。如果 sender 的话，那读的时候就很困难了。就是我要读的时候，我要去所有的地方都读一遍，看看有没有人 invite 我。
对，所以我说这个问题是个 open discussion，但是就是说，就是尤其在 review 的时候，你要有一个 solid 的一个 points 来支持你的，对吧？
对。
你做系统设计的时候，一些假设你要就是能让你的 points stand， 对吧？
好，
其实要题目的考察点，我感觉更多的还是在，就是听下来更多的是在这个schema 底站上，就是这个 database 这块。因为
我觉得这个 Calendar 系统其实有很多地方都没有考察到就说就看考官他感兴趣是哪一部分，就是说 DB 这一段可能就是 schema 可能他比较感兴趣，他可能会问多一点，但实际上这里面就是说比如说像 Google 一个 Calendar 系统的话，它其实有很多人都会 online， 然后你这个 server 你怎么 sync data 到你的 web client， 其实有些人也会问。还有一些人问的话，就是说，就是说这个数据的话，长期的话，就是说，就 DB 你怎么去存那些数据，然后就是说，然后你这个 query， 你的这个 index 怎么去优化，其实都是可以考的地方。而且我觉得这也很奇怪，就是因为这是一个很典型的 microservices 系统，但是在 architecture 上，这个 microservices 就没有体现出来，就是画了一个框就完成了。这可能我觉得这面也可以多深挖一点。这样的系统，很多时候 design 可能就需要1-2个月，并不是就是说一个 interview 就是能大体的把它走过了，它只能有一个侧重点吧，我觉得。
好，那再看看大家还有没有什么想法或者问题。对，好，那如果大家没有，那很感谢大家来今天我们的活动，希望下次和大家见面然后如果大家有这个需要准备面试或者是职场在需要职业规划或者职业提升也欢迎联系我们然后我们会可以给大家提供一些这样的服务这里是我们的工作人员的这个2维码那欢迎大家联系非常感谢大家来这次活动谢谢大家，再见。